Let me show you the cathode ray tube, and I always love to tell the kids that we're learning about CRT here, which is the original meaning of CRT. If you take a look at this power supply, it all looks pretty intimidating, but it's pretty basic. Good luck, Mr. Dugan.
Why, thank you.
This is the this 6.3 volts, 2 amps. That's just for the back, so you wire that to this thing here.
Oh, you're making demos.
Yeah.
Demo videos.
Demo video.
For the person that's doing this. I
know.
really hope that you enjoy it, because this is a great job.
This is a great job.
It's a good job.
Yeah. Good luck, Mr. Dugan.
Thank you.
So this 6.3 volts, 2 amps. That you just connect to the back side here, right? Because in the back there's like a little light bulb, and that's what it runs off of, right? And that's isolated up to whatever, how many kilovolts, right? And then if you notice, I've got there's 5.3 kilovolts. You got to be a little careful with that. And I take the negative side of that and just attach it on there. So I've stacked a banana. It doesn't matter which side you go to, because it's alternating current and it's isolated, right? Okay. And then what you want to do is you want to take the high voltage one, okay, and connect that up to the little iron cross thing. I don't know why it's an iron cross, but there it is, right? Okay, and that's sort of the rabbit, right? So the electrons are going to boil off of that hot filament, right? They're going to be accelerated through the, they're going to be accelerated through this, and there's I haven't really read the manual, okay, but they accelerate toward that iron cross. Some of them overshoot and hit that zinc sulfide screen on the end there, okay, and then you'll notice I've also taken the liberty of grounding this, right? So there's things you can do with this, and you could read the documentation. I just ground it because if a little static charge gets on that, it'll shut the whole thing down. So I've grounded that thing, okay? Now, what you want to do to turn this thing on, turn the voltage down, click this on, and if you click it on, you can see there's a light in there. This thing's just a very expensive light bulb, okay? But if I start to turn up this accelerating voltage, you can see that the electrons now are starting to hit that end there, like that, right? And you can turn it up even more, and it'll get even brighter. So at this point, just be really careful. That thing's at 5, right now it's at 2,000 volts. I'm pretty sure that wouldn't feel great if you touched it, right? And then things you can do with this, you can bring the Van de Graaff up, especially if you have that thing grounded, right? You can bring the Van de Graaff up, and you can show that the Van de Graaff actually will make that beam go away from it. So if I bring that ball up here, like this here, it's kind of dodgy AF, but you can bring the ball of the Van de Graaff up, and if it's charged up a little bit, you can actually get that beam to repel. Now we know these are electrons, right? And so if this thing's repelling it, if the dome is repelling that, if the dome is repelling it, this must also charge negatively, which Van de Graaffs can charge either way. And then the other thing you can do is you can bring the pole of a magnet in, right? If I bring the north pole in, have the kids predict what's going to happen. Now they haven't seen, by the time they see this, they haven't seen any of the rules for magnetism. And so you just get them, what is this going to do? Is it going to attract it, repel it, And of course, the answer is what? It pushes them up. Why is that? Why does it push it? It pushes the beam up. Why is that? Well, the velocity is this way, right? The magnetic field is that way, and so it's going to push them, well, negative up, because they're negative ions, right? So it's going to go up, right? And you could do that. You could take a South Pole magnet and you can mess with it. But anyway, that's the cathode ray tube. I think that's all I need to say.